Troy Lacey here with a lecture on minerals, their physical properties, and identifying common minerals. Minerals. Why do we care? First off, minerals are the building blocks of rock. All rocks are made of minerals, and Earth is made of rock. So it seems obvious that the study of rocks and the minerals they contain should be an essential component of the study of geology. Minerals also have practically unlimited economic uses. We use the ingredients of minerals, the elements, in the materials we use in our daily lives. In fact, it is estimated that every person in the United States will use more than 3 million pounds of rocks, minerals, and metals during their lifetime. The composition of the minerals in magma and in rocks dictate geologic processes like volcanic eruptions and the rate of erosion. Finally, minerals give an insight to past environments on and below Earth's surface. The formation of minerals. Minerals form through the processes of crystallization of magma and or lava, precipitation from water, and from precipitation from marine organisms. So these are three distinct processes and environments of formation for minerals. Minerals are made of elements, the naturally occurring ingredients of Earth and everything else that we know of. While some minerals may exist as a single element, like copper or gold, most are compounds, which form through the chemical bonding of two or more elements. Let's take a quick look at how this happens. Let's take a quick look at three different types of chemical bonding. First, ionic bonding. This happens when the atoms of one element transfer some of their electrons to the atoms of another element. This results in the atoms becoming oppositely charged, say positive and negative. Opposites attract, and the two become bonded together. Covalent bonding involves the sharing of electrons, and in this way, the atoms of the elements become bonded together. And metallic bonding is, think of it as kind of a group share of electrons. And again, in this way, the atoms of different elements become bonded together. Most minerals form from some combination of the 8 most common minerals in Earth's crust. Minerals are organized into groups based on composition. The most common group of minerals found in rocks are the silicates, which utilize the two most abundant minerals in Earth's crust, oxygen and silicon, to make up their crystal structure. These bond together to form the silicon-oxygen tetrahedron, to which other elements bond, creating other minerals. Depending on the concentration of iron and magnesium, silicates are organized into two main subgroups, the dark silicates and light silicates. The dark silicates being those that contain iron and magnesium, the light silicates do not. In either case, both are very common in the rocks of Earth's crust. There are over 4,000 minerals on Earth, but only a couple dozen are commonly found in rocks. Another important mineral group are the carbonates, which always include carbon and oxygen and are very common in sedimentary rocks. There are other important mineral groups as well that are discussed in your reading. The physical properties of minerals, just like the physical traits of people, are used to distinguish one mineral from another. Luster is a measure of how a mineral reflects light and is typically the first property considered. It is used to divide minerals into two broad categories, metallic and nonmetallic. Metallic minerals look like a metal, while nonmetallic minerals don't, although they can still be quite shiny. Additional adjectives are used to describe nonmetallic minerals, such as vitreous, earthy, silky, and others that are discussed in your reading. This photograph here is an example of a mineral with vitreous luster. Here we have one with earthy luster, and another with silky luster. And again, these three are non-metallic, while this one is metallic because it reflects light in a way that it looks like a metal. Hardness is a physical property that measures a mineral's resistance to scratching. Hardness is measured on a scale of 1 to 10, with the hardness of common minerals used to define the scale. Talc being the softest at 1, while diamonds being the hardest at 10. The Mohs hardness scale typically also includes the hardness of everyday items for comparison. Streak is the color of the powder of a mineral produced by scratching the mineral on a hard porcelain plate. Not all minerals will show a streak, but for those that do, it can be a diagnostic property because it consistently is the same color, while the color of the mineral itself oftentimes is not. It can also be helpful in identifying a mineral as having a metallic luster, because metallic minerals typically have a dark, bold streak. Cleavage is the tendency of some minerals to break along natural planes of weakness in the atomic structure of the mineral crystal. This results in a crystal with some or all sides being relatively flat and highly reflective of light. Cleavage is described as a number: 1, 2, 3, 4, even 6, or none in cases where a mineral breaks conchoidally or along curved surfaces, because there are not through-going planes of weakness in the crystal structure. Specific gravity is a measure of a mineral's density relative to the density of water, while crystal habit refers to the shape a mineral crystal takes according to the geometry of the atomic arrangement of the atoms when allowed to grow freely. Unique properties, or special properties as are also called, are characteristics that are uncommon and therefore can be diagnostic. A few examples are reaction with acid. Here we see a sample of calcite reacting with hydrochloric acid. Magnetism. Some minerals are magnetic. Striations. You can see these fine parallel lines across the face of this mineral. Those are the striations. And feel. Some minerals have a soapy or slippery feel to them. As mentioned earlier, there are over 4,000 minerals, and each has its own unique set of mineral properties. An important component of the study of geology is identifying the common rock-forming minerals, which in turn allows us to identify the name of the rock containing those minerals and the conditions under which that rock formed. Mineral identification is done using mineral identification flowcharts, like those found on pages 75 through 77 in your lab book, and determinative tables, like those found on pages 78 through 81 of your lab book. Because this is an online class, we don't have access to physical mineral specimens, so instead we will use photographs of some of the common minerals so we can have some fun trying to correctly identify those minerals. Thank you for listening. This is the end of the lecture.